Good afternoon, everyone. Thank you for joining our webinar this afternoon. As Michaela introduced, today I will go through a short presentation on the PIQCV, or pressure independent zone valve. There we go. Our agenda today is, I'll give you a short description of what a PIQCV is. I'll talk a little bit about the theory of pressure independent valves. I'll also talk about the effects of pressure independent valves in a hydronic system, and tell you how you can adjust flows in the PIQCV in the field, and lastly, where we see the PIQCV fitting in the HVAC applications. So our PIQCV is more than your standard zone valve. It's compact in size. It uses low power, so it's low power consumption on the actuator. It's zero leakage because it's designed on the ball valve technology. And we like to say it's efficient in every way. So what is a PIQCV? A PIQCV is a two-way valve that supplies a specific flow for each value of control signal, regardless of pressure variations in the system. Firstly, we should understand that systems are dynamic, and throughout the day, throughout the operation, systems are going on and off. We have zones going on and off. So this is a very dynamic system, and we will show you as I go forward some cause and effect in a hydronic system. So the theory behind the pressure independent valve is, in the event there is a change, we know there is diversity in hydronic system. In the event there is a change in the differential pressure across the valve, the flow coefficient, or CV, of the whole valve will change automatically so that the resulting flow, GPM, will remain constant. We have a little formula here that depicts that when delta P goes up, we want to maintain GPM, but if we're in a pressure dependent situation, when delta P goes up, so too does GPM. What we prefer to see is that delta P goes up and your GPM stays constant by adjusting the CV value in order to maintain a designed GPM. Let's have a look at the PIQCV technology. I mentioned before, it's built on a ball valve. It's built on the characterized control valve that Belimo has been selling since 1999. So it's the technology that you've known and trusted over the years. It's super compact in size, so it fits in small spaces. If anyone is familiar with our PICCV, you can see that the PIQCV is much more compact than the PICCV. We've designed the valve and actuator combination in such a way that in the field, you have the possibility to adjust your flows depending on the coil's GPM. So what I mean is, you buy a PIQCV with a nominal flow of X, and when you get to the field, you need a different flow, a smaller flow than the nominal flow of the valve. And while you're in the field, you have the ability to adjust the flow to match your coil's GPM requirement. We have a high close off of 100 PSI. We have zero leakage, and we have a 5-year warranty. So all these things combined in a compact zone valve. Let's take a look at a system and see how the effects of pressure changes affects flows in a hydronic system. So the picture we're looking at here is of a pressure dependent system where we have standard control valves and we have a manual balancing valve. So we have installed a pressure dependent valve. We require additional balancing valves in order to maintain some type of a flow requirement through the coil. However, significant effort is also needed to balance the system when we're using manual balancing valves, because manual balancing valves are static. You set them and they stay in that set position. They don't have the ability to dynamically change. With that said, pressure deviation in the system will equal a change in flow. So if you have an increase in pressure, you will have an increase in flow, even though there is a manual balancing valve. Likewise, if there is a pressure drop, a pressure reduction, you will have a reduction in flow. So I use this chart to depict that a pressure dependent system, although there is a manual balancing valve installed, you are not dynamically balanced. You're balanced at commissioning, and when the balancer walks the job and he balances every loop, at full load you're balanced. But once the system is in operation and you're operating at part load, or not all units installed are being operated, your balancing job that was done previously has been negated for the fact that there is diversity in the system now. Additionally, when selecting pressure dependent valve for a system, you must do some calculation. You need to know your GPM for your coil, that's a given. You need to have your differential pressure, and then you must do a calculation and a valve selection. So I have shown there the calculation to arrive at a CV for a pressure dependent valve. Let's look at some cause and effect. So in this scenario, I'm depicting a pressure independent valve on the upper rung of this diagram, and the bottom rung shows a pressure dependent valve. At this point, we have differential pressure of 5 psi in both loops, both the pressure dependent loop and the pressure independent loop. We're flowing 10 GPMs. Let's go ahead and change the pressure. So we've increased the pressure to 20 psi from the previous 5 psi. So both loops have now gone to 20 psi in differential pressure, and this is what we would expect to happen. The pressure dependent valve maintains 10 GPM, although the pressure has gone up from 5 to 20 psi. But the pressure dependent loop has now doubled in flow. So we've gone from 10 GPM to 20 GPM in your pressure dependent loop, although there is a manual balancing valve installed. Let's look at a pressure independent system. So in a pressure independent system, we have installed a single pressure independent control valve with no manual balancing valve. If you're using a pressure independent valve, you do not need and should not install a mechanical valve. You should not install a mechanical balancing valve. Again, because you're doing a PI control valve, no manual balancing is required. Pressure deviation in the system will allow you to maintain the PI valve will allow you to maintain design flow. And when you're selecting a pressure independent valve, it is as simply as looking at your coil's GPM requirement and picking a pressure independent valve that matches that coil's GPM. So no calculation is required when selecting a pressure independent control valve. For our PIQCV, we require a 5 to 50 psi differential pressure in order to maintain flow stability. So this graph, I'm showing how we are pressure independent from 5 psi to 50 psi across the range of pressures. With our PIQCV, we have integrated PT ports, and we can use these PT ports for measuring differential pressure. Again, we say in order to achieve pressure independence and volumetric flow according to design, we need to have a delta P within the range of 5 to 50 psi. So you would simply verify the differential pressure by using the PT ports that's installed on the PIQCV. We should be measuring 5 to 50 psi. Let's look at another scenario. While 5 to 50 psi is what we require to have pressure independence in our PIQCV, we can also experience some optimization. So when we're measuring delta P, the measured differential pressure across the PIQCV, if it's outside the optimum level, and I'm saying optimum level meaning greater than 5 psi, when measuring differential pressure that is greater than 5 psi, this is an indication that the pump speed can be reduced. And if we look at this diagram here, you can see that in this diagram, the pump speed is at 100%. Your power consumption is at 100%. By making a small adjustment, so now we measure and we see that we're at 15 psi differential pressure. We're using the PT port. By making a small adjustment, so the pump speed can be reduced until there is still a differential pressure of 5 psi across the valve, because that's the minimum we require. This can greatly reduce your power consumption of the pump. So therefore, we would lower your energy cost. So again, you see that the pump speed has been reduced to 70%, and your power consumption has gone down to 34%, because the power formula is a cube, so your ratio of change is that much greater. Our PIQCV has a few accessories that are available. The first accessory at the top in black is your stem adapter. You can use the stem adapter when you're insulating the valve. This allows you to give some distance between the valve body and the actuator, so you can insulate your pipe and insulate the valve without getting the insulation into the valve on the actuator. So it acts as a spacer. It's also error-proof, so it can only go on the valve in one of two directions, and the actuator will fit directly on top of the spacer, and that goes on in the same manner. So there is no chance of making an error when you're putting in the spacer or when you're putting the actuator on the spacer. We have a manual dial that we can use if you choose to use the PIQCV as a mechanical balancing valve. It can also be used as a mechanical balancing valve by using the orange flow setter. It attaches to the valve in a similar fashion as the actuator would, and you would turn the dial to dial in the GPM that you need for your coil. And you set it, and it will work as a manual balancing valve. The third item is an architectural cover. It's a simple design. The cover snaps right onto the actuator, no tools required. It's white, and it's finished in a manner that is paintable. So if you had a valve assembly that was exposed in a room and you wanted to paint the cover to match the decor of the room, you can do so because the texture of the cover and the finish of the cover is suited to be painted. The fourth device is a flow orifice, and the flow orifice is simply there to allow you to measure flow. Remember, the PT ports on the valve itself are only for measuring differential pressure. If you needed to measure flow, you would buy this additional device that you can measure across the ports with a manometer, and you would be able to correlate that correlate that pressure to a supply chart that will tell you what the flow is versus your differential pressure. I spoke earlier about being able to adjust flows in the field. So when you buy a PIQCV, and in this case, I'm showing a valve with a nominal flow of 4.3 GPM. If you wanted to have a 3.1 GPM for your coil, in the white space on the left, you would type in 3.1 GPM. You would hit the submit button, and on the right, at the upper portion of the diagram, it says move clip to position number 6+, and your GPM is 3.1, and your run time from 0 to your new clip position 6+ would be 64 seconds. This flow capacity tool is available on Belimo.com or ZoneTight.com. So you can go online and you have access to this tool in the field. At the bottom of the diagram, you see a button that says documentation. If you click on that button, it will bring up the technical and installation documentation for QCV or PIQCV. So the previous diagram, I showed you how to change the clip to adjust a different flow. Once you've done that, on our actuators, we have two basic types of non-failsafe actuators. We have an on-off / floating point or 3-point control, and we have a proportional control through the 10 volts. On your on-off / floating point actuator, once you've changed that clip position to a new angle less than 90 degrees, you will need to know what is the run time from 0 to that new angular position. This is included in the flow setting capacity tool as we saw before, but it's also included in the supply documentation that comes along with the valve assembly. For the proportional actuator, once you've changed the clip position, there is an LED on the face of the actuator, a push button. You push that LED button and the actuator will go left and right. It will drive left and drive right to learn that new angle and adjust the control signal to match that new angle so you can have access to your full control resolution from 0 to your new angular setting. We also have failsafe actuators, and we have two basic failsafe actuators as well. One that is an on-off and one that is proportional. Your on-off actuator, again, it's the same procedure. You would move the clip to your new position. You would look for the corresponding runtime from 0 to your new position. And this is the information you would need to know to program into your controller for your 0 to your new set position. The failsafe on-off actuator is also available with an integral auxiliary switch. So if you had an application that requires on-off plus a switch, this on-off actuator does come with an end switch. This model is available in 24 volts only, for both proportional and on-off. With your proportional actuator, again, once you've changed the clip to a new angular position, you would push the LED button for the actuator to learn its new angular limits and be able to rescale the control signal so you have full resolution. Some applications where we see the PIQCV being best fit would be for fin tubes or fan coils, VAV reheats, chill beams, heating cooling ceilings. And if you wanted to use it as a manual balancing valve, you could use it also as a manual balancing valve. So in summary, the PIQCV assembly set new design and performance standards for pressure independent zone valve. We're compact, we're built on the ball valve technology, unlike other small zone PI valves that are linear. The PIQCV, because it's built on a ball valve technology, it's self-cleaning. So as it opens and closes, it's cleaning itself. It's built on the Belimo technology and reliability that you know and trust, or damper actuator technology that you've known over the years is now available in a compact zone valve actuator. We offer a 5-year warranty for both the valve and the actuator, so the assembly has a 5-year warranty. Our actuator technology is our patented brushless DC motor technology. We have actuators that can run at a mere 0.3 watts. What does this really mean? That you're saving energy by using an actuator with very low power consumption, or you can buy a transformer of a smaller size, so less than a 40 VA transformer. Or if you had a 40 VA transformer, you can wire more actuators to a single transformer without having a concern of not enough power. The valves are zero leakage, and this eliminates lost energy. With some of the linear valves, as the seats wear or the stem has buildup or the seat has a buildup, you might be in your closed position, but you're not really closing off, so you can have some leakage. We're ultra compact and can be installed in tight spaces. Again, field settable. Flow adjustment, which is very simple. You just remove that gray clip and you reset it to the new appropriate position. Again, our PIQCV, it snaps together quickly. It requires no tools to apply the actuator to the valve or to set your flows. So it's a quick connect zone valve. We're compact in size, we consume very low power, and zero leakage. This is the end of my presentation. Are there any questions?
Thank you so much, Nigel. We do have some questions. For those of you who joined us partway through the presentation, just a friendly heads up that this webinar has been recorded and will be posted to our YouTube page at a later time. If you're looking for some information, we have included a brochure in the handout session. And as always, if you wanted to find out more information about the PIQCV, you can go to www.belimo.us. Nigel, are you ready for some questions?
Yes, I am.
Okay, first question. What is the largest size the PIQCV comes in, and what is the highest flow rate?
Our PIQCV, the largest size is a 3/4 inch with a maximum flow of 9 GPM.
Okay. What is the close-off pressure of this valve?
Close-off pressure is 100 PSI.
Okay. Next question, can this valve be installed outdoors?
We currently do not have a NEMA 4 or 3R rated actuator for this assembly, and we do not have a weather cover, so I would not recommend for it to be installed outside.
Okay. Can you tell me if the valves are available with the CRN number, the Canadian registration number?
CRN registration is not completed, but it's in the works. We have applied for CRN, but it's not completed yet.
Okay. Can I get 2 to 10 VDC feedback on my proportional PIQCV?
2 to 10 VDC. As of next month, you will be able to get feedback 2 to 10 volts on the actuator. I have one correction to a previous question about close off. The close off is 200 PSI. I said 100 PSI, it's 200 PSI.
Oh, okay. Thank you for that. Another question, is it possible to have the flows factory set here at Belimo?
Yes, we offer factory flow setting. Upon ordering your assembly, you would indicate what GPM you would like the valves to be set at before shipment.
Okay, going to do a last call for questions. As always, if you should have a question or comment after the conclusion of the webinar, you can contact myself, Michaela. You have my email address, and I will put you in touch with Nigel. I want to thank you so much for joining us today. Our next webinar is going to be on the 23rd of May, and that is going to be a fire and smoke webinar presented by Larry Felker. I want to thank you so much, Nigel, for doing an excellent job on this presentation. And again, everyone, have a great day and thanks.
Thank you. Goodbye.